Hi, we're back for problem 9.8, which deals with the idea that there's a potential shortage of PhDs to fill vacancies now in universities. So, in this particular case, they went out and surveyed 521 professors aged 55 to 64 and asked each one whether he or she intended to retire before 65. And the responses are 1 is a no and 2 is a yes. So we're supposed to estimate with 95% confidence the proportion of professors who plan on early retirement. So we've got our standard formula here, reminder, the p hat, and I just put p hat there so I can use it down here. We've still got our 4 commonly used confidence levels, and over here is data. It comes from the student data files that go with your textbook, but whether they plan to retire and salary. And so we're going to be looking at column A. So first thing I'm going to do is just type in the number in the sample, which is 521. And now we have to figure out, in this case, if they indicated a 2 here in this column, that means they're planning to retire early. So we need to use, well, we could go through and just count it manually, but there's no reason to do that. So I'm going to show you a function, equal, and the function is the COUNTIF function. So it counts the number of cells within a range that meet the given condition. So I'm double clicking on that. The first thing I'm going to do is put in the range. In this case, since the label retire is in A1, the range starts at A2. And we know that there's 521, so I'm not going to scroll down, but it actually goes to colon A522. And then I put the comma, and so that's the range, and now I put in the criteria. All I need to do is enter the number 2 for the criteria, close the parentheses, and click the check to enter, and it indicates that there's 55 professors planning to retire early. So we go down below this and go, let's calculate the percent. Equals 55 G11 divided by the 521. So 55 out of a sample of 521 are planning to retire early, which gives us 1056. Now it might come out a little something like that when you do it on your own spreadsheet. So again, I just rounded to 0.1056. So I'm going to put in 0.1056 here. Again, I'm typing it in because otherwise when we just display fewer decimals, it comes up with some rounding issues there. This makes it a little cleaner. So I've got the 1056, and again we want 95% confidence, so we're back to the 1.96, and then 1 minus p hat is equal to 1 minus p hat, and we've got the n, the sample size of 521 there. So now we're going to go over here, and I'm just going to merge and center that, and now I'm going to go equal to z times the square root, and in this case we want it of p hat times 1 minus p hat, which we've already calculated down here in cell F17, and in this case we're going to divide this whole thing by n, close parenthesis, hit enter, and it gives us number that I didn't think it was going to give us. Let's see. Maybe I need to verify. Let me pause for just a second. Okay, I'm back on this one. I'm going to delete this and do this calculation again because I think I put the parentheses in the wrong spot. So it's equal to, in this case, the z times the square root of p hat times 1 minus p hat divided by n and there we go, 0.0264. And now what I want to do is calculate the upper control limit, which would be equal to here, let me just get rid of this, 0.1056 plus 0.0264 equals, and again I'll do this calculation here, equal to p hat plus right here, and that is going to give us the upper confidence level, and then down below here 1056 minus 0.0264 is going to be equal to, and again let me do that actual calculation here, p hat minus, and again that would be the lower confidence level, and it's usually indicated up here, you've got the plus or minus, but in order for me to show it to you in Excel I need to do two separate calculations like that. So that gives you a sense of how that estimate works. So that's it for problem 9.8, and next we'll do 9.12.